All right, good afternoon or good morning or good evening, depending on what part of the world that you're tuning in from. We're glad that you chose to join us for this next hour or so on this webinar where we're going to discuss the National Building Code of Canada 2020 Firestop requirements and changes. Our instructor today is John Valioulis. He's the technical director for us here at the International Firestop Council, and we're grateful for him to put this together and to present that. Thank you, John, for doing that and being here with us. A couple of things you'll want to know. We always get questions on, is there going to be a handout available or a recording? So this is being recorded, so you will be able to go back and watch the recording on our YouTube channel, and we'll put it into our learning management system as well. Additionally, a handout is available. So on your screen, if you look up in the top right-hand corner, you'll see a picture of a paper clip and a document. If you click on that icon, you'll see that you can download the handout. There'll be a couple of poll questions throughout this that'll pop up. You can answer those poll questions for some interaction. And then finally, if you have any questions, again, in that top right-hand corner of your screen, you'll see a box with a question mark in it. Feel free to put your questions in there, and we will answer those periodically as we see fit. So that's it. Thank you, John, for doing this for us today, and thank you all for being here and being part of this. I'll turn it over to John to instruct the webinar. Thank you.
All right, thank you very much, Aaron. Just making sure that everyone can hear me. All right, thank you everyone for being here today. We are going to start with the poll question, just so we know who's on the line, since obviously in a webinar we can't see you, all of you. So Aaron, if you can put up that poll question, what do you do for a living? Please let us know. Okay. Aaron, do you want to close that up? All right, what is the result, Aaron?
So we have, out of nearly 150 people online right now, we have 39% are from contractors or from the trades, 37% are engineers, 10% is architects or other specifiers, and 15% are code enforcers or AHJs.
Okay, well, welcome to everyone. It's a shame we don't have more architects. Obviously, they have to write the specifications. So if some of you know some architects, please have them watch the video sometime after today. So what are the objectives for today? Well, we're going to talk about joints and about penetrations. So, my misbehaving screen. Here we go. Talk about joints and penetrations. We'll talk about joints first. Why? Because that's where the change is the largest in the 2020 National Building Code of Canada. So we're going to speak about how the fire stopping of joints was governed by a general continuity requirement in previous editions, and how now in 2020 edition, there are some very specific joint requirements telling you pretty much exactly what to do. For penetrations, we'll do similarly. We'll talk about the 2015 and previous NBC code requirements, just so we have that as a baseline, and then we'll go through the changes in the 2020 code. All right, so we're going to structure the agenda as follows. First, we'll just do a general Firestop overview. We'll discuss joints. We'll discuss a very specific joint after that, the perimeter joint, also known as the curtain wall edge of slab joint. We will discuss penetrations, penetrations that only go through one side of the wall, meaning outlet boxes. Then for those of you who work in smaller buildings, known as Building Code Part 9, we'll just discuss any differences and similarities between the Part 3 buildings and Part 9. So the general presentation today will focus on Part 3 of the Building Code, because that's for large and substantial buildings. I will give you the differences in Part 9 in case you do work on those buildings. Now let's discuss fire separations. I'll discuss in a moment what the definition of a fire separation is, but the important thing to realize is that it's the building code that decides which assemblies are going to be fire resistance rated fire separations. So when it comes to walls, wall fire separations are more commonly based on what is being protected. So for example, if it's a corridor, that would be a fire separation, a fire rated corridor, maybe protecting individual dwelling units. separating different occupancies, separating hazards in a building. So that would be the need for fire walls within a building. And then the code will separately, usually independently, also require fire rated floors. And those will be more of a function of the height and the area of the building. So the bigger the building gets, the more likely you're going to need a fire rated floor, and it may even go to 1 hour, 2 hours or more. And also the taller building gets, you'll also need more fire rated floors. Why? Because in each case, what we're trying to do is win a race. And the race is between the fire starting, growing and spreading, smoke spreading, fire spreading, and people trying to get out of the building, as well as first responders needing to get into the building to do whatever they're going to do, whether it's search and rescue or fire suppression. So just to give an overview of how the National Building Code of Canada has evolved on fire stopping, it is not new. In the 2005 and 2010 editions, it only touched on the basics. It was very kind of rudimentary. There were some confusing and I would call ill-advised exceptions or specific requirements, things that added confusion more than clarity. The definition of fire separation was improved in those cycles, so that was a good help. In other words, telling us what our fire separations are all about. In the 2015 edition, there was a revision made to add membrane penetrations, meaning holes for outlet boxes, and we will discuss those in detail. Now in 2020, this is where there was a large number of changes. The committee put together a Firestop task group for several years with some great representation from across the country. Very highly knowledgeable people from UL, ULC, from each of the provinces, from some of the cities. And so they just did a great job at revising the code to really bring it pretty close to the state of the art. A lot of the bad exceptions that existed previously were deleted, and where there was some vagueness or things were causing confusion, clarity was added to those code articles. Now, some improvements can still be made. Unfortunately, those won't come out in the 2025 edition. There were some other priorities for the code committee. They had a shortened cycle since the 2020 code only came out in April of 2022. So that shortened cycle, really, there was no opportunity really to prioritize or work on anything Firestop related. So hopefully in 2030 edition, there may be some further improvements. So next, let's talk about what is fire stopping. I'm going to start with an unofficial definition, and after that, I'll show you the code definition. So unofficially, but maybe more clearly, fire stopping is a precisely tested means and methods to restrict the spread of fire and smoke through breach or gap in a fire resistance rated assembly. So in other words, you have this perfectly good 6-sided box with 1 hour, 2 hour, 3 hour, 4 hour rated fire separations, but you're going to have holes in it. Now, today we're not going to deal with doors and windows. That's a seminar for another industry and another day. But today we will deal with all the joints that are inevitable in that construction, and we'll deal with the penetrations in that construction as well. Now, the code does have a definition. The definition itself has not changed, but they have changed the word. For some reason, the 2015 and previous editions of the NBC were somewhat of a laggard. It was the only standard out there that was using fire stop as 2 words. Now they've pretty much harmonized, including with the fire test method. So it's just 1 word, fire stop. So if you had been using it as 2 words, I'd encourage you to just harmonize as well and start using it as 1 word. So here's the code definition. It is a system, and I want to pause there because that is the single most important word. So I'm glad it's right at the beginning. It's not a material, it's not a red caulk, it's not a product in a box, it is a system. It consists of a material, component, and means of support used to fill gap between fire separations or between fire separations and other assemblies. So for example, between a wall and a floor, even if the floor was not rated, or used around items that wholly or partially penetrate a fire separation. So if you have anything going into a fire separation, or if it goes all the way through, those require fire stopping as well. So we're going to try another poll question, Aaron. So let's take a look at the questions first. What is a fire stop as per NBC 2020? So hopefully you paid attention in the last 3 minutes. Aaron, if you could launch the poll question, please. So let us know what you think a fire stop is based on the code definition and on the unofficial definition. Aaron, if you can, it would be great if you could show the results of the poll after you close it. Okay, excellent, great. People are paying attention. So it's a system used to fill gaps in a fire separation. Wonderful. So by the way, a few of you nevertheless said it was a material that can seal a hole in a fire separation. In fact, that's not correct. It is not a material. It is always a system. So please keep that in mind. All right, sharing the screen. Oh. All right, okay. So continuing on, I said that I would give you the definition of a fire separation. So the code has a very neat and tidy, just few words for that. It's a construction assembly that acts as a barrier against the spread of fire. So almost self-evident. But in the National Building Code of Canada, if you're not aware of it, there is a section called the Annex 1. And what they do there is basically non-enforceable, but it's the committee giving you additional information so that you would help understand what the enforceable parts of the code say. So there's a very useful annex note for the definition of fire separation. It's generally understood that the term fire refers to all products of combustion, including heat and smoke. So that's useful to know, and that we're going to want to stop heat and smoke through a fire separation. Although fire separation is not always required to have a fire resistance rating, it should act as a barrier to the spread of smoke and fire until some type of response is initiated. If the fire resistance rating of a fire separation is permitted to be waived on the basis of the presence of an automatic sprinkler system, it is nonetheless the intent of the code that the fire separation be constructed so that it will remain in place and act as a barrier against the spread of smoke until the sprinklers have actuated. So by the way, this might surprise you. There are some fire separations that are going to be 0 rated. As this annex note tells you, it still has to stop the movement of fire and smoke until some kind of response is initiated or actuated. Now, the most common case for that is where there's a sprinkler trade-off in the code. So the code is good at pretty much telling you what you must do, but in some cases the code only gives you the option or the incentive to put in fire sprinklers in the building. And when it does that, it often does that by reducing the rating of a fire separation to 0. Now, candidly, as you look out in building construction, 95% plus, maybe 98% plus of fire separations will be fire resistance rated. But some may be 0 rated, so just making you aware of that. So as I said earlier, we're going to discuss fire stopping as 4 separate major categories. We'll talk about through penetration fire stops, membrane penetration fire stops that only go through one side of a wall or one side of a ceiling, fire resistive joint systems, and then one very specific joint system, and that's the perimeter fire containment system, what you do at the edge of slab at the curtain wall. Let's start with joints. So here we have really generally 4 typical or most commonly types of joints. So we have the head of wall referred to, or HOW, you might see that acronym, also known as top of wall joint between a wall and the floor above. We might have head of wall to a fluted deck or a flat deck. These joints might be floor to wall, they might be floor to floor, wall to wall, and also not shown here is the bottom of wall. So if you have a wall and it stops 1 centimeter short of the floor, then in fact you don't have continuity. Something needs to be done there to maintain the fire resistance rating all the way to the next assembly. Here's what the 2015 code said. So this was the text, and it was called continuity of fire separations. The continuity of a fire separation shall be maintained where it abuts another fire separation, a floor, a ceiling, a roof, or an exterior wall assembly. So as I mentioned, if you have a rated wall, no matter what direction it goes to, up, down, sideways, it has to be continuous all the way until it abuts an adjacent assembly of some kind. And here we can read the annex note from 2015 code and earlier. The continuity of a fire separation where it abuts against another fire separation, floor, ceiling, or exterior wall is maintained by filling all openings at the juncture of the assemblies with a material that will ensure the integrity of the fire separation at that location. So previous to the 2020 code, they were still using the terminology of material. And why is that? Because if you look at the definition or the requirement for continuity, it doesn't mention anything about a test or what the test should be or what the rating of the test should be. So really, it was very simplistic. It just said you needed to do something. Now, fortunately, Canadian design professionals seem to be very knowledgeable and have been installing systems nevertheless for more than a decade, but the 2015 code did not exactly say that. So now let's compare that to the 2020 code text. For continuity of separations, it's the same section title, but now the content is very different. So here's what it says. Except as provided in sentence 5, the continuity of a fire separation having a fire resistance rating that abuts another fire separation, a floor, a ceiling, or a roof, so in other words, side to side to top to bottom, shall be maintained by a fire stop. So notice that earlier on it had said a material, now it says maintained by a fire stop, conforming to sentence 3. Sentence 3 will now give us the details of how we accomplish that. The fire stop required in sentence 2 shall have an FT rating. So now we know the rating, and I'll explain what the ratings are. Not less than the fire resistance rating of the abutting fire separation when subjected to the fire test method in CAN ULC S115, standard method of fire tests of fire stop systems. So the key points to remember here, it has to be, the joint has to be sealed with a fire stop. The rating is an FT rating, and I'll show you the ratings. And it's tested in the standard Canadian test, which has been used for decades, which is CAN ULC S115. You'll see a reference to that multiple times today. So there is a definition of a joint fire stop system. Now note that in the definition, well, let me go through the definition first, is a fire stop system that provides a seal along a continuous linear opening between two fire resistance rated assemblies or bounded by a fire resistance rated assembly. In other words, sometimes it's where a fire rated assembly meets a non-fire rated assembly to prevent the spread of fire. Now, in the test method itself, CAN ULC S115, it does not mandate that you have to achieve any kind of rating, as long as you achieve an F rating, which is the fire rating. The T rating is essentially optional, but as you saw in the previous slide, the T rating is now mandatory in the 2020 code. You need an FT rating. So how do we measure these F and T ratings? Fire is just the passage of flame, passage of fire. And the T rating is done by putting thermocouples on the non-fire side of the test assembly. So you can see the thermocouples here. They're little electrical pads, I'll call them, or electrical probes. They have a little pad on top of them so that we're not measuring the room temperature, we're measuring the joint temperature. And when it gets too hot on the non-fire side, that's the point at which we have failed the T rating. So now I've shown you a picture of a rather small assembly here. The dimensions of the test apparatus are maybe about 1 meter by 1 meter, sometimes a bit larger. Now, some joints have to be tested in much larger scale furnaces. In other words, it's the same scale as the CAN ULC S101 furnace, and that's expansion joints. Expansion joints are those large joints you see in a parking garage or that you don't see in a building between major pieces of the building slab. And so those are much larger, the gaps are much larger, they may be 100 millimeters or even 200 millimeters. And because of their size, they have to be tested in much larger scale furnaces, but the ratings are the same, and basically the test method is analogous, just in a bigger scale. Now, another thing we have to remember with joints is that joints in a building will actually move. Very few joints are static, most are dynamic. Why is that? Because things are happening to a building all the time. As an example, when you have a floor slab, it doesn't look like it, but as you add a live load to that floor, it will move. As it gets warmer and colder, things expand and cool, you will get movement. When wind blows on a building, you get movement. And of course, if you're in a seismic area, you know for sure that if there happened to be a tremor or an earthquake, there will be movement. So the code does mandate that we consider, that the designer and the installers consider that movement. So this is not new to the 2020 code. That was already required in previous editions of the code. If I look at Annex Note A3181, here's the exact words. When choosing products for fire stopping, the physical characteristics of the material used at the joints, as well as the nature of the assembly and its potential movement, should be taken into consideration. So the reminder has always been there that don't forget about the movement in selecting your joint. Now, in case you're wondering how we test that movement, we actually test it before doing the fire test on the joint. So it's per an ASTM test standard, ASTM E1399, tells us exactly how to run that cycling. It's basically 500 cycles essentially in most movement tests. So you can see on the left the picture, there are hydraulic jacks that basically cycle that joint up and down, closed and open, closed and open. And so this is how we make sure that once the joint is installed, it will survive and continue moving through the life of the building. There's been a good annex note added to explain joint continuity. I'm not going to go through all of it. You have it in your handout, so if you want to read it at your leisure, but I'll just point out a few of the things that are important here. For example, it does talk about joints being needed in the first paragraph, even without a fire resistance rating, where it abuts a fire separation. Next, in the middle paragraph, what I want to point out is that there's a separate requirement for curtain wall joints. So we will get into that in more detail, but it's discussed in more detail here in the annex. But finally, what I wanted to mention is what's in the last paragraph. So once again, the code is reminding us about movement. So if you look at where it's underlined, it says the rating of the joint system will be maintained even after the joint has cycled through its anticipated range of movement over the service life of the building. Most joints between fire resistance rated assemblies, other than those between load-bearing elements, experience some movement over the service life of the building. So if someone proposes to you a dynamic, a static joint system, you should ask a few questions. And even if someone proposed to you a dynamic joint system, someone has to verify that it will accommodate enough movement as the design engineers or architects will tell you needs to happen. Now, because the code added this very clear section on joints, it was felt that it was important just to mention that you don't need a joint fire stop system wherever you have a joint between two boards. So a brand new section was added to the code under continuity, and basically it's for the joints at corners and between walls and floors when you have gypsum board. Essentially, it's telling you that if you have the joint as required in the ULC, fire tested assembly, fire listed assembly, that you don't need fire stopping there. So basically the thing to remember is if you read the listing for rated walls, you're going to find that it always tells you need butted joints. As soon as the boards are apart, physically apart, then they're no longer butted. But if you have butted joints, it's perfectly fine to mud and tape them. Same goes for the interior corners, exterior corners, etc. So now we'll start another poll question. Aaron, if you can launch this one. So which are true regarding joint fire stops? And I'd like you to click all the ones that you think are true. More than one is true. Aaron, I see that you have to scroll it down a bit so people can see all 4 potential answers. Or wait, or does the user do that? I guess the user does that, I apologize. So there are 4 potential answers, and if you could click on the ones that you think are true regarding joint fire stops. And I'll tell you already, more than one is true, but let's see if you can figure out which one is true and which one is not. Okay, so click on the choices that you think are true regarding joint fire stops. All right. Aaron, if you could show us the results. There we go. All right, so must accommodate expected building movement. Perfect, so everyone got that. Must have an F rating equal to fire separation rating. Uh-oh, that's trouble. Non-native gap is less than 1 millimeter. If you said that, no, that is in fact incorrect. If you look at the listing for any wall assembly, rated wall assembly, it requires the wall to be have the joints butted, meaning the boards are in physical contact, and there's no dimension given in fact. Now it's known that boards are not perfectly straight, they get dented, they're maybe not cut perfectly straight, but there's no dimension when you don't need anything. But congratulations, people got it right on the last one, not needed between butted gypsum boards with tape joints. Now, one that I have to reemphasize is that the rating for joints is not an F rating, it is the FT rating. So you need to prevent fire spread, and a code compliant joint system has to prevent the temperature from it being exceeded on the non-fire side. So for those of you who said you need an F rating, you were halfway there. In fact, what I want you to remember is that you need an FT rating. So good halfway there, but let's remember that we need an FT rating in all cases. All right, so for those of you who are AHJs, I'll make it easy for inspection and plan review. First of all, ask for the listed system used for every joint type that's either in or between fire rated walls or floors. All right, if someone's gonna be just walking around with a caulking gun, that is not gonna cut it. Fire stopping is a system. Joint fire stops are a system, and there's no system that's just a caulk in a tube. There are some preformed materials these days that are preformed joint systems. So ask for the listed system. There are over 2,100 listed systems for Canada. Next is if you're doing an evaluation, make sure that the proposed system has the FT rating. So I just went over that review after the quiz, the poll. Okay, you're looking for an FT rating in all cases for joints per the 2020 code. And then if you're truly doing a verification, whether you're the architect, engineer, or AHJ, make sure that the field conditions meet the Firestop system exactly. Every system has a very precise set of conditions, so make sure it's installed exactly that way. Next, we'll discuss a very specific joint, the curtain wall edge of slab joints, the perimeter joint Firestop. So I think if you haven't seen a curtain wall before, prior to installation of finished materials, knee walls, etc., there was always going to be a gap between the floor slab and the curtain wall, as the word would hint, I guess, that it's a curtain. And here's what the 2020 code now tells us. Except as provided in sentence 5, joints located in a horizontal plane between a floor and an exterior wall shall be sealed by a Firestop. So pause there, Firestop being a system. That when subjected to a fire test method in ASTM E2307, aha. So this is interesting. It's not the standard fire test method we use for penetrations and joints. It is a very particular, much larger scale test method for the perimeter joint. It's ASTM E2307. Not a new test standard. It's been used, it's been issued almost 20 years ago, and it's been used in the US building code for almost that long. And then the rating you need from that is an F rating, the fire rating. So notice in this case, you do not need the FT rating. Why is that? Because curtain walls are made up mostly of metal, and it would be essentially almost impossible to get an FT rating. Why? Because all the metal pieces would be conducting heat from the floor below to the floor above, and the FT rating is just not a practical objective. So for curtain walls, for the curtain wall joint, you only need to get an F rating. Now, I want to mention that it mentions, or the code says that you need this when the joints are located in a horizontal plane between a floor and an exterior wall. All right, so the requirement for E2307 system is in the horizontal plane between the floor and the exterior wall. This leaves a little bit of ambiguity as to what to do when you have a window wall. So in this case, I just have the cross section of a window wall meaning that the wall is sitting load-bearing right on top of the floor. It is not in a separate plane. It is not hanging down like a curtain. So per a plain reading of the code language, theoretically, this would not need any fire stopping. This would, if someone does ask for fire stopping, there are systems for that. For example, this one that I'm showing here is a system where you can see that the sealant is below the floor and above the floor. But a plain reading of the system or of the code requirement is that you do not require a fire rated system per E2307. What I would suggest though is in case there's any ambiguity, whenever there's gray areas or ambiguity, it's the authority having jurisdiction that makes the final call. And so if you're unsure in your jurisdiction, then find out from the AHJ. But as I said, a plain reading would indicate that this would not require any fire stopping. Now I want to show you more about this ASTM E2307 test. It's called the intermediate scale multi-story apparatus. It's intermediate scale because it's not quite full scale. We build buildings much taller for one given floor. This is, I think, about 3 meters tall, actually less than 3 meters, maybe about 2.5 meters for the bottom floor. And of course, we know that a true story is taller than that. It has the fire in the room on the underside, on the ground floor, I'll call it. So the fire is started there at time 0, and then at T equals 5 minutes, a second burner started called the window burner. And the intention of that is to simulate what happens after flashover. Flashover is when flames break the window and come essentially licking along the side of the window after the flashover occurs and the window breaks. And so the test is designed to, as realistically as possible, simulate that. So it has the fire in the room down below, and it has the fire essentially exposing that joint from the outside. Now, what I need to emphasize with all that is that E2307 is a wall system test. It is not merely testing the joint. Now, the joint is where the fire stopping is going to happen, or where we're going to have to do something. But that fire stopping is going to be heavily, heavily dependent on the behavior of that curtain wall. In other words, that curtain wall has some reaction to fire. It might bend, it might buckle, it might droop, it might sag, it might hopefully not fall out completely. And so what we have to do at the perimeter gap is going to be heavily dependent on the behavior of that spandrel panel or of a shadow box or back pan, etc. And so we understand that the curtain wall is not rated. Nobody in any country is building fire-rated curtain walls. It would be dramatically too expensive. But nevertheless, that curtain wall, even though it's not fire resistance rated, still has a reaction to fire. And so the key variable here is the behavior of that spandrel when exposed to fire. So system listings for ASTME 2307 will always include great details on the spandrel construction, the height of the spandrel, what is the position of the spandrel, does it line up with the floor, does it line up several centimeters above the floor, what is it insulated with, how is it reinforced. Of course, we also need the details of the safing material. The safing gap is that gap between the floor slab and the curtain wall. So the system will tell you in great detail what forming material you need there, what compression, etc., and what material you need to seal that. Now, by the way, that doesn't just seal the smoke and hot gases. That seal on the joint also acts kind of a glue to hold it all together. Without that, to be honest, when that curtain wall would flex, a lot of it would probably come apart. So just to give you one example of how detailed this can be, I just pulled up one random system, Intertech. Not mentioning the manufacturer of that system, but it's BPF system 120-12. So for that back pan, it would mention that it's a steel back pan. There are no systems with aluminum back pans. That would just not do well in a fire. It has 8 PCF, 8 pounds per cubic foot mineral wool. It has to be 150 millimeters thick, or 75 millimeters thick, sorry, for the spandrel installation. Now for the joint packing material, it's 150 millimeters thick. It will mention the brand name and product name for the insulation. Some people may think of mineral wool as just a generic material. It is in fact not at all. Just like anything else we put in a construction site, these materials are designed and engineered and made to have certain properties. So there are mineral wools that are great for sound absorption or for thermal properties, and some are just better for fire resistance. And so you do have to make sure to choose the right mineral wool material. So in this case, it's thermofiber safing. You have to choose the one with the right density. So in this case, it's 4 pounds per cubic foot. And very importantly, it has to be compressed by the right amount. And the compression allows that joint to kind of expand and contract as that spandrel panel moves. Otherwise, you're going to get a gap. And then finally, there's the Firestop joint spray, which again is a given manufacturer, given product. It's going to specify its wet thickness, dry thickness, and whatever overlap it needs onto the floor and onto the wall. So where you'll find these listings are in the UL and ULC directories, but I want to bring your attention also to the Intertech directory. Pretty much a slim majority, just a bit more than half of Firestop listings are in the Intertech directory. Many reasons for that. Intertech has been doing this kind of testing for many decades. There are years where UL was not doing any testing at all. And so Intertech just has many of these listings. So if you're not familiar with Intertech, you may want to become familiar, because probably at least half, if not a bit more than half of all curtain wall Firestop listings are in the Intertech directory. I should mention there is no difference between Canada and the US. So when you look up the listings, doesn't matter if it says UL, ULC, ASTM, whatever, it's really all the same because there is only one curtain wall fire stopping test in North America, E2307. Now, I want to mention that you want to be on the lookout, because in 2015, it would have been very easy for a manufacturer to provide an engineering judgment for a curtain wall. Why? Because what it used to say, and I have the wording here from 2015, all you had to do was fill all openings at the juncture of the assemblies. So if you had the floor slab, all you had to make sure was that safing gap, that it had a fire resistance rating that extended to the curtain wall. But there was no part of that code, of the 2015 code, that said you had to consider what's going to happen to the curtain wall during a fire. So now, under 2020, the joint system is clearly tested E2307. That's absolutely a system test, very, very heavily dependent on the curtain wall behavior in a fire. So if you're doing plan review, for example, if you're an authority having jurisdiction, your code enforcer, make sure that any engineering judgment you get or the system you get matches the spandrel construction of the actual building. Same thing, that you have to match the height of the spandrel panel, its position relative to the floor. Is it to go above the floor or not? That makes a big difference. What is the insulation of the spandrel panel, the reinforcements, again, the safing material. So you have to get a perfect match or near perfect all of those. Now, I mentioned a few red flags here because eventually you're going to get an engineering judgment proposed to you by someone who is optimistic, hoping that perhaps you'll accept their engineering judgment, but in fact may not be a good match. Why? Because there's so many curtain wall designs out there, and most manufacturers have done some fair number of curtain wall testing to E2307, but perhaps none that match the curtain wall that you're about to construct. And so if you see words like this, be aware that it may be because that manufacturer is telling you very openly that they don't have a match. So curtain wall designed by others. That's the manufacturer of the engineering judgment telling you, we don't know what the curtain wall is, we don't care, it's by someone else. And well, here's your engineering judgment that just talks about the gap. You might get some words that are a little more involved. Rating of the system is dependent on performance of the untested curtain wall. Yes, we know all curtain walls are untested, but basically you really should have a test with something similar to determine what to do at that joint. That is the principle behind E2307. Or some similar wording, rating of up to X hours, whatever the engineering judgment is proposing, or as long as the assembly remains intact in a fire scenario. Very true. They're telling you very truthfully that they know their safing material will be as good as long as that whole curtain wall does not fall out. But here's the thing, is that under 2307, ASME 2307, they have to have done some testing to get some inclination of how that curtain wall will behave when exposed to fire. So these details matter, by the way, and it had actually happened. There was a high-rise fire in downtown Los Angeles, and one of the key learnings from that was we better do the curtain wall fire stopping right. So here's what happened. The picture on the right shows the curtain wall. Because it was not properly fire stopped and there was some deflection of the curtain wall, the safing at the gap just fell to the floor below, and there was premature fire spread from one story to the next, always through that curtain wall gap. So history has taught us that yes, it does pay to do curtain wall fire stopping correctly. And like I said many times now, that does involve considering how the curtain wall will behave. So let's try a poll again. So which of these factors will impact the time to failure of a perimeter joint fire stop system? So there's more than one answer here. So please click all the ones that you think will impact how long the perimeter joint fire stop system will last. Will it last a whole hour? Will it only last 2 minutes? So which of these elements of that system do you think will have an impact? So click on the ones you think will impact the fire resistance. All right, Aaron, we could probably close it. All right, so very good. The vast majority clicked all of them, and that in fact is the correct answer. All of these will definitely impact the fire resistance you get from a perimeter fire containment system, from a curtain wall fire stop system. So the compression of the mineral in the safing gap, absolutely critical. The height of the spandrel panel, very important. The spandrel construction details, yes. Is it steel? Is it aluminum? Does it have reinforcing angles? What is it insulated with? What type of mineral wool? What brand? What density, etc. And then finally, the joint fire stop spray, absolutely, the type and the thickness of that. If it's too thin, not going to work. If it's the wrong type, not going to work. So all of these are in fact very important. All right, continuing on. Next, let's discuss penetrations. Through here, you just have a sampling of penetrations. It's not necessarily one pipe, one hole. We often put multiple penetrations through one hole or a slot or something like that. Top right, probably a hotel or a condo or something like that. You see all the plumbing penetrations. I wanted to show you bottom left because you might think, well, geez, that's wood. Does that really have a fire resistance rating? And the answer is absolutely. There are plenty of buildings built of stick frame with wood floor ceiling assemblies, and those assemblies will have a fire resistance rating and do need to be fire stopped just like any other fire separation. So what is the requirement here? This has not changed that much from the 2015 and previous editions. What I'll show you is with the strike-through wording and the underlined wording, the only changes. So here's what this tells you to do. So except as provided in census 2 to 7, so as usual, there are some exceptions. Penetrations of a fire separation or of a membrane forming part of an assembly. I find when I explain this, a lot of people don't quite understand what that latter part means, membrane forming part of an assembly. So I'll have a slide coming right up that'll show you what that means. But for now, know that if you penetrate a fire separation that needs a fire resistance rating, what do you have to do? You have to seal it by a Firestop. So again, remember that's a system. When subjected to fire test method, CAN UL-CS 115, so you know the test method. And the default is that you must have an F rating. So it means that you don't have to have a T rating. It's okay if it does not have an FT rating, but it must have an F rating. And here's the change, is that the code previously said that that F rating need to be no less than the fire protection rating of the assembly. The fire protection rating is just the rating we give to doors and windows. And if you didn't know, those are usually 3/4 of the rating of the fire separation. So in a 1-hour wall, you'll have a 45-minute door or fire 45-minute rated glass. So nobody's really been developing Firestop systems that only have 3/4 ratings like this. All manufacturers have been doing full fire resistance rating of full hour, 1 hour, 2 hours, 3 hours, etc. And so the code was changed to essentially harmonize with what's being done in practice, which is to require that the F rating be no less than the required fire resistance rating of the fire separation. So now notice in that first sentence, it said that penetration of a fire separation or a membrane forming part of an assembly. Let me explain that in just a little bit more detail. A lot of times when floors are built, the floor structural materials, in fact, have no fire resistance of their own. So it might be wood, it might be wood 2x10s, 2x12s, it might be wood trusses, it might be lightweight steel joists, steel bar joists. And so these things really do not perform well in a fire. But nevertheless, there are ample UL, ULC listed assemblies for floor ceilings that involve these materials. And here, of course, is the secret of how they do that, is they have a membrane on the underside that essentially gives them that longevity in a fire. That membrane on the underside is protective and protects that floor that otherwise would not have any fire resistance rating. The membrane could typically be 1 or more layers of gypsum board, typically type C, ceiling type gypsum board. Some systems are with type X, wall board. There are actually some systems with mineral board type, just like you would see in a drop ceiling. There are systems like that that provide fire resistance rated floor ceiling assemblies. So now when we go back to the code language, sorry about that. When we go back to the code language, now you'll understand what it talks about when it says penetrations of fire separation or a membrane forming part of an assembly. As you can imagine, if you make a hole in that membrane on the underside of one of those floor ceiling assemblies with very poor fire resistance, that is heading towards the collapse of that floor, premature collapse. And so that is equally important, maybe sometimes even more important, as fire stopping of a full fire separation. So next, again, we discussed the ratings. F is the time for flame to penetrate to the unexposed side of the fire rated assembly. T means the temperature rise wasn't too high, and the test standard in the code defined too high as a temperature rise of 181 Celsius above the ambient temperature. If you meet both F and T, then that's called an FT rating for CAN UL-CS 115. And just in case you see it, so you'll know what it is, if you see FH or FTH, H stands for a hose stream test. In the US, that is mandatory. It's been mandatory for probably 100 years or more. And so if there is an FH or FTH rating, it means that that system would also be eligible to be listed for US applications, meeting the International Building Code. So now you might have noticed that there was option A in Firestops, and that was basically a Firestop system tested to CAN UL-CS 115, but there is also an option B, and it's been there for years and years, and it said cast in place. Now here's the problem, just putting the words cast in place doesn't quite cover it. Why? Because if something you cast in place will melt or burn, that's going to leave a big hole behind. So for example, I'll play a little video here. Okay, so I know it's a bit pixelated, but this is a 4-inch PVC pipe cast into the floor. And as you can see, essentially it doesn't accomplish anything useful. This is for sure not what the code intends as the desired situation. A fire separation is intended to stop fire and smoke. And so this absolutely does not do it. So recognizing that some more words were needed to make this a proper exemption or a proper specification, the code has now specified that cast in place is acceptable where the item penetrating the fire separation is steel, ferrous, copper, concrete, or masonry. In other words, all things that will not melt and will not burn. So importantly, notice that aluminum is not there. I know that aluminum conduit is becoming more and more popular. If you cast in an aluminum conduit, it is going to have to be fire stopped. Why is that? Because aluminum will melt in a standard fire. Now, by the way, there is a section on combustible DWV pipes, which doesn't allow cast in anyway, which it never should have. But just so you'll know, if you had been in the habit of looking at cast in things, make sure that now and in the future, you only cast things that are not melting and not burning. Now, here's an example of something that is completely inadequate, and actually it's an actual photo from the field that the installer thought this was adequate. So what you see here are PVC pipes cast into the concrete, and some electrical services pass through that. And the contractor was fully convinced that this meant the cast-in exemption. So first of all, maybe it might have in the past for the sleeve itself, since it was cast in and it didn't have any other requirements. But here's why I would say this never met code and doesn't meet the code previously or today. And that's by reading the annex note for that code article. So if you read the annex note for penetrations, it says the intention behind the use of the term cast in place is to reinforce that there are to be no gaps between the building service or penetrating item and the membrane or assembly it penetrates. So no gaps, just remember that and you're good to go. No gaps between the building service or penetrating item. The term cast in place describes the typical means of fire stopping for service penetration through a concrete slab or wall. So here we can see in this installation here, obviously, even though that PVC was cast in, you do have a gap around it. So now, even if you do cast in a steel sleeve, keep in mind that you're going to have to fire stop on the inside of it because you cannot have a space between the service item and the assembly. So in the left one, I think that's quite obvious. That's just a blank opening. There are fire stop systems for that. The one in the middle, maybe a bit smaller hole, and the one on the right, very, very small hole, but nevertheless, these all have to be fire stopped. Now, just for those architects, engineers, specifiers who aren't aware of it, if you're planning to do cast-in sleeves anyway, the modern way to do that is to cast in a fire stop device. That way, it does not have to be fire stopped after the service item is passed. Here you see just a schematic of a fire stop cast-in device on the left. This one is with a metal deck adapter. There are systems that are made for corrugated metal decks so that the concrete doesn't pour into the hole. On the right, in case you're wondering what that contraption is, that's a tub box. So it's precast. You see the fire stop cast-in device, and it even casts in ready for a bathtub. And so there are all kinds of really clever accessories in the cast-in lines with the fire stopping. And so definitely I encourage you, if you're not familiar with them, please take a look. Most manufacturers have cast-in devices. So the fire stopping is built right into those. The way they work is that they have the fire stop material. They have intumescent strips that are basically built into these devices. Now, this is the first time I've used the word intumescent. So let me show you a short video to give you an idea of what intumescent means. So in this case, it's showing the video of a cast-in fire stop device. And with the intumescent strip, it's being exposed to heat. And now you're going to see what that intumescent product does as it's exposed to that heat. And what it does, it basically closes up the hole. And believe it or not, it does that with quite a bit of force. One of the properties that we can measure with intumescent materials is not by how many times they expand, but also with how much force they expand. So if there was a plastic pipe here, as it melts, this would actually crush and close the plastic pipe, thus preventing the fire from spreading to the next room or the floor above. So we're ready for another poll. So how do you prevent vertical fire spread? This is an actual situation, so you're ready to be amateur fire stoppers now. How do you prevent vertical fire spread for a cable bundle routed through a steel sleeve cast into a concrete floor? So there's only one correct answer, so choose the correct answer that you would do to fire stop a cable bundle through a steel sleeve that's cast into a concrete floor. So there are 4 choices, so take a look and see which you think is the correct one. All right. Oh, this is a great group. Everyone's paying attention. Wonderful. Good to hear it, even though we're getting on in the webinar. So the few of you said nothing needs to be done since it's cats in place. No, that's incorrect, because there's still the cable bundle going through the inside of the sleeve. That needs to be fire stopped. Filling with grout, thank you. Nobody said yes, because no point filling something with grout if it's going to burn or melt, such as a cable bundle would. And a polyurethane foam, I guess one of you said that. Absolutely not. That's going to burn out in just minutes, maybe even seconds, maybe less than a minute in a fire. So good job, everyone. Congrats. And continuing onwards. So now, and there are a few cases where the penetration fire stop is going to need not just an F rating, but an FT rating. Essentially, those are 3 cases, so I've itemized them here. You're going to need an FT rating for the penetration in firewalls. So firewalls are true, structurally independent walls that don't collapse in the event of a fire. Most of the walls that you and I and we all see are fire separations. They're not true firewalls, because why? They will come down if there's a fire eventually. A true firewall will stay standing even if the building completely collapses. So they're few and far between. The next type of thing you need to have an FT rating for is for the horizontal separation above a garage. So if you're going from a garage to a retail area, garage to a residential, that last concrete floor is going to need an FT rating for the through penetrations. And then finally, if you have a penetration through a horizontal service space separation, that penetration needs an FT rating as well. Just so you'll know, horizontal service space is not the same as a plenum space. It's not just the space above your ceiling. It's where basically you have, I'll call it a horizontal shaft, where the separation truly is structural, has its own supports, not just something hanging like a ceiling. In case you're wondering if the penetrations you've seen out in the field had an FT rating, they would look something like this. That the FT rating, the T part, is not really generated by the fire stop per se. It's generated by some kind of insulation. Basically, you have to keep the heat from getting into the penetrating item or the heat from getting out of the penetrating item. So it's going to be a lot more onerous, a lot more expensive. And so don't specify an FT rating where you don't need it. Matter of fact, the code has now given us some exemptions to the T rating. One exemption is similar to what's shown in the photo here, or the image, is if your penetration is concealed in the wall both above and below the separation, the floor, you don't need an FT rating. If your through penetration is concealed in a rated floor ceiling assembly, or if that ceiling is even better, it's a horizontal fire separation, or it's a horizontal service space, then the penetrations above that would still need an FT rating, an F rating, but would not need an FT rating. Now, before we finish with penetrations, I want to mention that the code has written some good additional information in the annex. In that first paragraph, you see a good reminder that it's not only for building service, but also for structural elements. So if you have a cable bundle and you have a pipe, beautifully fire stop, great, but make sure you fire stop that steel joist going through or that steel beam. In the middle paragraph, you see a reminder that fire stopping is an assemblage of materials. It's a system. And in the very last paragraph is a good reminder that the flexibility of the material used at the joints, as well as the nature of the assembly and potential movement, must be taken into consideration. So just some good annex material, just reminding you of doing the right things right. Now, in the previous code, 2015 and earlier, there were some code exemptions that were not really clear. They said that certain things were permitted without testing, and they were often misinterpreted as not without fire stopping. So nothing is further from the truth. For example, it mentioned 25mm cable bundles without testing. It did not mean without fire stopping. Here's just a short video of a 25mm bundle in a very tight 25mm hole in a concrete slab. You can see that that's not a success. There were some other exemptions that are also a bit vague, so those were all deleted from the 2020 code. There's now a replacement for that, just to make sure that there's no confusion. There's now a blanket requirement for, there used to be a requirement that said that everything going through an assembly had to be non-combustible. And that was basically a leftover from decades ago when there were not fire stop systems for everything. That's been deleted because now there essentially is a fire stop system for everything. And just to make sure that people are aware that absolutely any penetration needs to be Firestop, there's now a new blanket requirement for all service equipment penetrations, saying they're all acceptable provided they're protected at the penetration with a Firestop. Now, speaking of Firestops, there's what I'll call a normal Firestop and a super Firestop. And the super ones are much harder to design. A normal penetration Firestop is tested in that furnace at a pressure of 2.5 Pascal. The number doesn't mean much to you, but it's a very, very low pressure. For a plastic pipe going through a building, that needs an additional higher pressure on the fire test, and that's 50 Pascal, 20 times more. So it used to be, it used to be that that was needed in all buildings if you had a plastic pipe running through multiple stories. Now for the 2020 code, it's only when you exceed 3 stories, so 4 stories and above. Now there is a section on transitions, which is a bit deceiving. It says that if you have a transition between combustible and non-combustible, you need a pressure differential of 50 Pascal for the Firestop. I just wanted to clarify that that's not really required for where the metal goes through. So if you just take my schematic here on the right, where the plastic pipe goes through, absolutely, you might need 2.5 or 50 Pascal based on the height of the building. If you have a transition point, you may need something to Firestop that transition point, but where you have the metal going through the floor, there was no intention in the code to require 50 Pascal for any metal pipe. Now, since the code does now mention transitions, there was some good data brought forward to the code committee that showed that if you have a non-combustible vent stack, so a non-combustible DWV pipe, that it's perfectly fine to have combustible branches. That does not require any special fire stopping at each floor. So again, it's a non-combustible DWV pipe with a combustible branch. The code accepts that without any specific fire stopping, just for the plastic branch. As a summary, these are the plastic pipes that would need the 50 Pascal, the bigger pressure, the hyper pressure on the fire test. The code specifies those based on usage, so water distribution, DWV, central vacuum systems, and polypropylene pipes. All right, so let's do a knowledge check. Actually, I'll be honest, we're gonna just blow through right this one. I see I'm running short on time. So which don't require Firestop system tested to Cannual CS115. The only penetration out of these choices that would not require it would be a steel pipe cast into a concrete floor. Cable bundles all the time, plastic pipes, doesn't matter the building height, CBVC sprinkler pipes, all of these would need a Firestop system. So if you're doing plan review, again, fire stopping for penetrations, just like for a joint, it must be a system. So if you're the one charged with checking, make sure it's a listed system and verify that the field conditions meet that listed system. Let's next quickly talk about outlet boxes. I am running short on time. It's important to realize that outlet boxes means all recessed boxes, not just what you would think of as where you plug in your computer or something else. So it's enclosures for electrical equipment, big boxes, laundry boxes, shower diverters, etc. The code has required this now since the 2015 code, so this is not new. The requirement for outlet boxes is that you have a Firestop system with an FT rating. Now here's the good news. Anything listed in the ULC directory will have an FT rating when it comes to outlet boxes. So you don't have to worry, does it or doesn't it? UL has decided that anything they list for Canada for outlet boxes will have an FT rating. In the 2015 code, there was somewhat of an exception done, said you didn't need to be incorporated at the time of testing. It was somewhat vague wording on plastic combustible electrical outlet boxes. It was realized that that was causing confusion. Some people didn't realize that they still need to be fire stopped. So that wording was deleted in the 2020 code. And it was replaced with something much clearer that says that basically, yes, combustible outlet boxes are allowed, but they must be sealed at the penetration with a system having an FT rating. Now for steel boxes, they don't all need to have fire stopping. It is permitted to waive the fire stopping for steel outlet boxes, but you have to meet 4 conditions. So first of all, they can't be too big, not more than 25 square inches. You can't have too many, not more than 100 square inches per 100 square feet of wall area. The annular space around the box can't be too big, and that's defined as 3 millimeters. And finally, they can't be too close together on opposite sides of the wall, and that's defined as 600 millimeters. So, and that's a horizontal distance. You don't mention it in a straight line. You mention it like 2 plumb lines dropped from each box. And if you don't have 600 millimeters apart on opposite sides, you're too close, and that needs fire stopping. So the code does remind us in option C here that if the only thing you're missing is that they're too close, a good way to solve that problem to prevent a zigzag fire spread from one side of the wall to the other is with a Firestop needing an FT rating. So we're going to skip this as well. Just want to remind you that you have to meet all of those with the metal box so as not to need a Firestop. They have to be not too big, not too many, and not too close together. Now let's just discuss Part 9 buildings a little bit. So in case you're wondering if you thought Part 9 buildings wouldn't even have fire separations, absolutely they might. The most common would be for separation of different occupancies. So here's an illustration from a National Research Council of Canada publication, just giving an example of a live-work unit. Now for through penetrations, they did add the option A, of needing a Firestop system. But they did leave in place the options from the previous editions of the code to be tightly fitted or sealed to maintain the integrity, or tightly fit or cast in place. Now, those are somewhat vague. If you read through all of Part 9, and we don't have time for that today, sometimes option C is not allowed, sometimes option B is not allowed. But in most cases, option B might be allowed. Now, if option C is allowed for your specific situation, the annex indicates what that should be. They refer to it as generic Firestop materials, even though there really is no such thing as a generic Firestop material. But for a Part 9 building, it is a much smaller building, 3 stories or less, 600 square meters or less. They do allow some penetrations to be sealed just with mineral wool, gypsum plaster, Portland cement. Now, to be honest, that may or may not work, and that's why option A is really to Firestop. But if the code allows it and you decide to do it, I guess you are code compliant. But the preferred alternative would be, of course, to have a true Firestop system. Now for joints, I won't go through the wording. It's identical to what's in Part 3. And so a Part 9 building needs all joints Firestop, just like a Part 3 building. And by the way, for a curtain wall, not mentioned here, but a curtain wall, again, has the exact same wording as in Part 3 of the code. If perchance your small little Part 9 building has a curtain wall, then yes, it would need to be Firestop, just like a Part 3 building code building. So a quickie quiz. Again, Aaron, we won't run the poll, but in Part 9 buildings, which must always be Firestopped, and essentially it's outlet boxes, joints, and curtain wall gaps. Always, the wording is identical to Part 3 of the building. There are some cases in Part 9 buildings, though, where through penetrations might get a relaxation. So you have to really dig through the specific situation in Part 9. So you'll have this in your handout. It's basically a review of all the changes I've gone through today. What I wanted to mention is that if you wanted more information, please refer to the IFC's website for that. We put all the Canadian information on one handy page, so it's easy to remember, firestop.org/Canada. Couldn't be easier than that. So we have some useful reference guides that you can download. There are some magazine articles there that were published by Construction Canada magazine that go over a lot of these changes. And there's a great little video published by the National Research Council of Canada, Canadian Board for Harmonized Construction, about 20 minutes long, doing the same thing as I just did today, maybe a lot more briefly, just in 20 minutes, going through the changes. You see, if you do go to that page, I encourage you, if you're not already on it, please join our mailing list. Now, finally, for those of you who are with jurisdictions, the IFC has always offered throughout its 30+ year history to do live seminars for code officials. So if you're a code official and you thought, hey, this was good information, the IFC does offer live in-person NBC 2020 Firestop seminars. Just send a request to info@firestop.org and we will hook you up. We'll get presenters on a mutually agreeable date. And you can let us know if you just have a little bit of time, like today, kind of rushed, to be honest, 1 hour, better would be 2 hours, 3 hours, or 4 hours. So we do have an NBC 2020 seminar that could be 4 hours long, and that will go into lots of great detail, make it really easy to understand. So with that, I'll ask my colleague, Aaron. Aaron, are there any questions or comments you'd like us to address?
Yeah, thank you, John. There is one question. Regarding section 3.1.8.3 on FT rated joints, what happens when we have a structural member or non-combustible penetration through the plane of the joint? Does the penetration now require an FT rating?
Okay, so it's a very good question. Candidly, it's a gray area because the joint is the joint, the penetration is the penetration. And we recognize that if you put anything metal through that joint, it's going to get hot and it will not have a T rating. So technically, the code says your joint should have an FT rating, not your penetrations. The default for penetrations is F rating. So I'll say that maybe a very strict reading of the code would exempt that penetration, even if it's going through the joint, from having an FT rating. Maybe a more nuanced reading of the code would be, well, you'd say that that penetration is now going through the joint. But if you think about it, that penetration has not done anything to harm the rest of that joint. Yes, it will be hot at that point, but it was always assumed that penetrations will get hot. Why? Because metal penetrations get hot, and the code does not intend those penetrations to all be insulated with 300 millimeters or 400 millimeters of insulation, or 100 millimeters even. And so really the person to ask would be the authority having jurisdiction to find out how they would enforce it. But I would argue that a very plain and verbatim reading of the code would exempt that penetrating item from needing an FT rating. So as long as the rest of the joint has the FT rating as needed, then that should be an okay situation.
All right, thank you, John. That's it. Do you have any closing remarks?
My closing remark would be, if you've gotten a taste for the information today, I had to leave out a lot of information. It was a real debate for me because we do have a 4-hour seminar that's a lot more complete, discusses a lot more situations. What do you do with damper ducts and ducts? And what do you have to do with sprinkler heads? And, why do we even Firestop, etc. So especially if you're jurisdiction, we invite you to send an email and request a free seminar at your location. We'll do it at wherever you need at your location. And we will send some qualified instructors to instruct.
Awesome. Thank you, John, for putting this together and for teaching this for us. We appreciate it, and thank all of you for joining us today. You'll get a follow-up email that'll have a recording and a certificate and all of that enclosed. So thank you all. Have a great afternoon.